Let's take a look at this example. Please notice that in this problem we do not have given the impedances of the capacitors and inductor, okay, but we have given the frequency. Please notice that frequency, okay, of each voltage source is the same. Okay, so we can find the impedance of the capacitors and inductors. So we can find ZL1, and the formula is always 2 pi FL, and because I want to find the impedance of L1, okay, I'm going to write 2 pi FL1, and this is equal 2 pi times the frequency, and the frequency is equal 5 tori hertz times the inductance, which is equal 600 millihenries. Okay, so my ZL1 is equal, I have 2 pi times 500 tori times 600 exponent 3 negative. This is equal, I can say, 2 kiloohms. Okay, so I have 2 kiloohms, and ZL goes always with angle of 90 degrees. Next, we're supposed to find ZC1. ZC1 is equal 1 over 2 pi FC1. This is the formula, okay? And I have 1 divided by, open parenthesis, and I have 2 pi times F, which is equal 5 tori hertz times C1, which is equal 100 nanofarads. Okay, so ZC1 is equal 1 divided by, open parenthesis, and I have 2 pi times 5 tori times 100 exponent 9 negative, close parenthesis. This is equal 3 kiloohms, and angle of negative 90 degrees, because when we look for the capacitor, okay, and when we look for the impedance of the capacitor, the impedance goes always with angle negative 90 degrees or negative J. Next, we're supposed to find the impedance of the capacitor C2. So I have ZC2 is equal 1 divided by, open parenthesis, 2 pi FC2. Okay, so this is equal 1 divided by, open parenthesis, 2 pi times 5 tori hertz times C2, which is equal 60 nanofarads. Okay, so I have, this is equal 1 divided by, open parenthesis, 2 pi times 5 tori times 60 exponent 9 negative, close parenthesis. This is equal 5 kiloohms. Okay, so I have 5 kiloohms and angle of negative 90 degrees. Okay, so this is my Z of C2. So I have the impedances of capacitor C1, I have impedance of capacitor C2, and I have impedance of the inductor L1. So now we can find the impedance Z11. Impedance Z11 is the sum of the impedances in loop 1. Okay, so Z11 is equal to the sum of resistance R1 plus CL1 plus ZC1. R1 is equal 4 kiloohms plus ZL1 is equal, we found over here, this is my ZL1, 2 kilo ohms and angle of 90 degrees, plus ZC1, which is equal 3 kilo ohms and angle of negative 90 degrees. This is equal, so I have Z11, I'm going to use the calculator, so I have 4 exponent 3 plus 2 exponent 3 and angle of 90 plus 3 exponent 3 and angle of 90 negative. This is equal 4.12 kilo ohms and angle negative 14.03 degrees. Okay, so I have 4.12 kilo ohms and angle of negative 14.03 degrees. Okay, so this is my Z11. Next, I'm supposed to find Z12, which is equal to Z21. Z12 and Z21 is the impedance between loop 1 and loop 2. Let me remind, this is my loop 1, and I'm going to have loop current I1. This is also called mesh current. Okay, in loop 1, so this is going to be my loop 2, I2. So there is no resistor or capacitor or inductor between these two loops. That's why I'm going to say that Z12 is equal to Z21 and this is equal 0 ohms. Because I do not have any impedance between these two loops. Next, I'm supposed to find Z22. Z22 is the sum of the impedances in loop 2. So I have in loop 2 capacitor C2 and resistor R2. That's why I'm going to write that Z22 is equal R2 plus ZC2, where R2 is equal 2 kilo ohms plus ZC2 we found is equal 5 kilo ohms and angle of negative 90 degrees. Again, I'm going to use the calculator. So I have 2 exponent 3 plus 5 exponent 3 and angle of 90 negative. This is equal 5.38 kilo ohms. Okay, so this is 5.38 kilo ohms and angle of negative 68.19 degrees. Okay, so this is my Z22. Next, I'm supposed to find the sum of the voltages in loop 1. Okay, so I have sum of the voltages in loop 1. So please notice that I have a positive sign of V1 on the left side. So theoretically, this voltage source is going to push the current from the positive terminal to negative. So if it is going to push in this way, I mean clockwise, this direction is going to match to direction of I1. That's why I'm going to say this is my positive V1. And V2 is going to push the current up, okay, because I have positive sign at the top. So I'm going to simply go in the opposite direction to I1. That's why I'm going to write that I have negative V2. Okay, remember, anytime the voltage source is going to push the current in the same direction like your loop current, the voltage source in your equation is going to be positive, and if it is going to push in opposite direction to the loop current, you are going to write the negative sign like I did over here for V2. So now we have V1 has value of 9 volts peak and angle of 30 degrees. So I have 9 volts and angle of 30 degrees minus V2, which is equal 12 volts and angle of 50 degrees. So I have 12 volts and angle of 50 degrees. Okay, use the calculator. So I have 9 and angle of 30 minus 12 and angle of 50. This is equal 4.69 volts and angle of negative 89.01 degrees. Okay, so this is my sum of the voltages in loop 1. Okay, so next we're supposed to find the sum of the voltages in loop 2. Okay, in loop 2 we have two voltage sources. We have V2 and we have V3. V2 is going to push the current up, okay, from positive terminal to negative. So the direction of the current pushed by V2 is going to be the same like I2, and V3 is going to push the current down, so the current is going to go in the same direction like I2. That's why I'm going to simply add these two voltages. So I have V2 plus V3, where V2 is given is 12 volts and angle of 50 degrees plus V3, which is equal 5 volts and angle of negative 45 degrees. This is equal 12 and angle 50 plus 5 and angle of 45 negative equals 12.59. So this is 12.59 volts and angle of 26.69 degrees. Okay, so this is my sum of the voltages in loop 2. So now we can say that we are ready to write the mesh equations, okay, because we have two loops, we are going to have two equations. First I'm going to write the general formula for the two loop circuit, okay. So I have formula which says Z11 I1 minus Z12 I2 is equal sum of the voltages in loop 1. Okay, so this is the first formula, okay, for the first loop, and I have negative Z21 I1 plus Z22 I2 is equal the sum of the voltages in loop 2. Okay, so this is my general formula for two-loop mesh analysis. Next I'm going to substitute these and these by the values which I get. So I have Z11 we found is equal 4.12 kiloohms and angle of negative 14.03 degrees. So I have 4.12 kiloohms and angle of negative 14.03 degrees. I1 minus Z12, we said that there is no impedance between loop 1 and 2, that's why I'm going to write there this is 0. So this is 0 ohms, and I have I2, and I have sum of the voltages in loop 1 is equal 4.69 4.69 volts and angle of negative 89.01 degrees. Okay, so this is my first mesh equation. Next I have to find, okay, the second mesh equation. So I have negative Z21, we said is equal 0 ohms. 0 ohms, and this is my I1. And I have plus Z22. Z22 we found is equal 5.38 kilo ohms and angle of negative 68.19 degrees. So this is 5.38 kilo ohms and angle of negative 68.19 degrees I2. Okay, and this is equal 12.59 volts and angle of 26.69 degrees. Okay, so I got my two mesh equations. Because my calculator doesn't solve the linear equations with the complex numbers, I'm going to use determinants to find the values of the currents I1 and I2. Okay, so I'm going to find the delta first. Delta is equal, I have 4.12 kilo ohms and angle of negative 14.03 degrees, and I have 0 ohms, and I have 0 ohms, and I have over here 5.38 kilo ohms and angle of negative 68.19 degrees. Okay, so my delta is equal, okay, this value times this minus this times that. Okay, so I'm going to have simply, okay, the product of 4.12 exponent 3 angle of 14.03 negative times 5.38 exponent 3 and angle of negative 68.19. This is equal 22.16. Okay, and I have exponent, times 10 to exponent 6, so this is mega ohm square. Why omega square? Because I have ohm times ohm is equal square. Okay, and I have angle of, my angle is negative 82.22 degrees. Negative 82.22 degrees. So this is my delta. Next, I'm supposed to find the number. I call this NI1. This is the number which is going to help me find the current I1. Okay, so what I'm supposed to do? I'm supposed to simply replace the column I1 by the voltages. So I have my voltages 4.69 volts and angle of negative 89.01 degrees, and my second voltage is 12.59 volts and angle of 26.69 degrees. And next I'm supposed to copy the column I2. So I have 0 and I have 5.38 38 kilo ohms and angle of negative 68.19 degrees. Okay, so we're supposed to solve it. Okay, I have to multiply this term by this minus this times this. So this times this minus this times that. So I have 4.69 and angle of 89.01 negative times I have 5.38 kilo, 5.38 exponent 3 and angle of negative 68.19, negative 68.19, okay, minus 0 times anything will give me 0. That's why I'm not going to even enter this into the calculator, simply press equal. This is equal 25.23, okay, and I'm going to have kilo, and this is going to be volt times ohm, because I have volt times ohm, okay, and angle of negative 157.2 degrees. Okay, so this is my NI1. Okay, this is the number which will help me to find the current I1. Now we can find I1. I1 is equal NI1 divided by delta. Okay, as I said, NI1 is the number which helps me to find I1. I call this number like that. So I have 25.23 kV ohm and angle of negative 157.2 degrees divided by, okay, delta, and we found that the delta is equal 22.16 mega ohm square and angle of negative 82.22 degrees. Okay, so this is the delta which we found over here. So next we're supposed to use the calculator, okay, and get the answer for I1. So I have 25.23 exponent 3 and angle of 157.2 negative divided by 22.16 exponent 6 and angle of 82.22 negative. This is equal 1.13 milliamps and angle of negative 74.98 degrees. Okay, so this is my current I1. Next we're supposed to find NI2. Okay, so what we're supposed to do, we're supposed to solve the determinant, and we have to copy down the first column from the delta, and the second one we're supposed to replace by the voltages. Okay, so I'm going to do that. So I have 4.12 kilo ohms and angle of negative 14.03 degrees, and I have 0 ohms, and I have my voltages right now 4.69 volts an angle of negative 89.01 degrees. Okay, and I have 12.59 volts and angle of 26.69 degrees. Okay, so I have NI2 is equal, again I'm going to use the calculator, so I have to multiply this term by this, minus this times that, but 0 times anything will give me 0, so I'm going to simply just multiply these two numbers together. So I have 4.12 exponent 3 an angle of 14.03 negative times 12.59 angle of 26.69. Okay, so this is equal 51.87. Okay, so I have 51.87 kilo volt ohm and angle of 12.66 degrees. So this is 12.66 degrees. Okay, so this is my NI2. This is the number which will help me to find I2. So I have I2 equals NI2 divided by delta. NI2 is equal 51.87 kilovolt ohm and angle of 12.66 degrees divided by delta, and we found delta is equal 22.16 mega ohm square and angle of negative 82.22 degrees. Okay, so omega and square will cancel out. Okay, so I have volt divided by ohm will give me amps, so simply perform the division. 51.87 exponent 3 an angle of 12.66 divided by 22.16 exponent 6 an angle of 82.22 negative. This is equal 2.34. This is 2.34 milliamps, an angle of 90.88 degrees. Okay, so this is the value of my current I2. Next, we're supposed to find the voltage across resistor R1. So please realize that the voltage across resistor R1, okay, so this is the voltage across this resistor, okay. We have current I1 going through this resistor, so if you want to find the voltage across this resistor, you're supposed to simply multiply I1 by R1 and you'll get the voltage VR1. So let's do it. VR1 is equal I1 times R1, where I1 we found is equal 1.13 milliamps. Okay, we got this over here. An angle of negative 74.98 degrees times R1, which is equal 4 kilo ohms. Okay, so this is equal 1.13 exponent 3 negative an angle of 74.98 negative times 4 exponent 3 is equal 4.52 volts and angle of negative 74.98 degrees. Okay, so this is my voltage VR1. Next we're supposed to find the voltage VL. Okay, so I call this VL1. VL1 or VL, because we have just one inductor in the circuit, is equal, let's take a look at the diagram, the product of current I1 and ZL1. Okay, because through the inductor current I1 will flow. So I have I1 times ZL1. So I have I1 1.13 milliamps and angle of negative 74.98 degrees times ZL1, which is equal 2 kilo ohms and angle of 90 degrees. So VL1 is equal 1.13 exponent 3 negative angle of negative 74.98 times 2 exponent 3 and angle of 90. This is equal 2.26 volts. 2.26 volts and angle of 15.02 degrees. So this is my voltage VL or VL1. Next we're supposed to find VC2. VC2 is the voltage across capacitor C2. Please notice that current I2 goes through the capacitor C2. So in order to find the voltage across this capacitor, we're supposed to multiply I2 by the impedance of the capacitor C2. So I have VC2 is equal I2 times ZC2, where I2 we found is equal 2.34 milliamps. So this is 2.34 milliamps and angle of 94.88 degrees times ZC2 we found is equal 5 kilo ohms and angle of negative 90 degrees. Okay, so VC2 is equal 2.34 exponent 3 negative angle of 94.88 times 5 exponent 3 and angle of 90 negative is equal 11.7 volts and angle of 4.88 degrees. Okay, so this is the value of VC2. Okay. Next, we're supposed to find the power at resistor R2. So if I'm going to look at the diagram, okay, so I have power at resistor R2. My R2 is in the loop 2. So current I2 will flow through the resistor R2. That's why I'm going to use this current to find the power. So I have P R2 is equal I2 square, okay, I2 square times R2, okay, and we have to multiply everything by 1/2 or divide by 2. Why? Because we are dealing with the peak voltages. So if you want to find the power, okay, for the peak values, you're supposed to use the formula which says P is equal 1/2 I squared times R, or we can say P is equal 1/2 V squared over R, okay? If you're using RMS, you don't supposed to multiply by 1/2, but if you're using peak voltages, because in our diagram we have peak, peak, and peak, that's why we're supposed to divide everything by 2, or other words, multiply by 1/2. So I have 2.34 milliamps raised to the second power times R2, which is equal 2 kilohms, and we have to divide everything by 2. So I have P R2 is equal, okay, so I have 2.34 exponent 3 negative raised to the second power times 2 exponent 3, okay, equals, divided by 2, is equal 5.47. This is 5.47 milliwatts. Okay, so this is the power at resistor R2. Next, we're supposed to find QL1. QL1 is the reactive power at the inductor. Okay, so this is my L1. I have to find QL1, and current I1 flows through the inductor. That's why I'm going to use the current I1 to find the power. So I'm dealing with the peak values. That's why I'm going to write this is 1/2 I1 squared times ZL1. So I have 1/2 times I1, and we found that I1 is equal 1.13 milliamps to the second power times ZL1, and ZL1 is equal to 2 kiloohms. Okay, I'm not using angles over here, so I have 0.5 times 1.13 exponent 3 negative square times 2 exponent 3. Okay, so I have value of 1.27 millivolt ampere reactive. Okay, so this is the reactive power of my inductor. Next, I'm supposed to find QC1. Okay, QC1 is equal 1/2, because again I'm dealing with the peak values, and this is my C1. I1 goes through the capacitor C1, that's why I'm going to use this current. So I have I1 to the second power times ZC1. So I have 1/2, and current again I1 1.13 milliamps raised to the second power times ZC1 is equal 3 kiloohms. Okay, so this is equal 1/2 times 1.13 exponent 3 negative square times 3 exponent 3 equals 1.91 millivolt ampere reactive. Okay, so this is the reactive power of my capacitor at my capacitor C1. Next, I'm supposed to find Ix. Ix is the current which will flow through this branch. Okay, so I have to find how much current will go through this wire. Please notice that this current is the combination of current I1 and I2. So this current I1 flows like clockwise and is going to approach this part of the circuit from the top, and this one is going to flow from the bottom up. So they're going to oppose each other. So in order to find the current going through this wire, okay, this connection, we're supposed to simply subtract them. So I have Ix is equal I1 minus I2, where I1 we found is equal 1.13 milliamps and angle of negative 74.98 degrees minus I2, which is equal 2.34 milliamps and angle of 94.88 degrees. So this is equal, I have 1.13 exponent 3 negative and angle of 74.98 negative minus 2.34 exponent 3 negative and angle of 94.88. This is equal 3.45 milliamps, 3.45 milliamps and angle of negative 81.82 degrees. And now I can say that the problem is solved.